All right, let's take a second here to call to mind God's presence. Does anyone have any special intentions? I'd like to pray for a good day. For that intention and any others, let's say Hail Mary, Father, Son, Holy Spirit, amen. Hail Mary, full of grace, the Lord is with thee. Blessed art thou amongst women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners now at the hour of our death, amen. Lift Jesus in our hearts. Those guys that are way over here, if you want to mix in for the next 2 weeks over here to be closer, that's fine. You don't have to, but there's open chairs here. So, I asked you to do a couple things for today, right? Yesterday's Zoom meeting, right? I told you to print the notes. I told you to print the vocab. Make sure you've got both of them out, okay? Actually, save those because I'll get to them tomorrow. They're the ones I'm going to use. I'm going to finish up the first packet of notes today, okay? How many don't have them? How many didn't print the notes?
I can bring my printer with my app.
No, why? Ask it. No, no, I'm supposed to look.
Yeah, Liam. Dude, you're like the excuse maker of all time.
That's why.
What? No, I haven't gotten any notes. You turned in a vocab. For what, on Friday?
Yeah.
Let's read. Okay, we're going to read through this. Okay. It's brother, by the way. Finish the vocab sheet on chemistry. It must be handwritten on the sheet that can be found on Schoology. Please turn it in with your name on it to the sub by the end of the class. It doesn't say anything about notes. Vocab sheet. Guys don't understand that vocab and notes are different. Guys don't understand that turn it in by the end of the class. After that is late. 0. These are all things you should bring to class every day. This is what we work on. And that vocab sheet, when you walked in Friday, should have been half done anyways. Over half. Because we had just done that. Yes or no? Because if you're doing what I ask you to do every day, if you don't, that's on you. I don't care if you don't care. It's just the way it is. Okay? So, copy the notes, copy the vocab. It's going to be the second vocab you're going to have to turn in. You just got the first one back from Friday, right? Hey, you turned it in Friday. When was the next day we met? Today. Did I have them corrected and given back to you by today? Did I actually correct them by yesterday and post them? Why do I have to do what I have to do and you can't do what I ask you to do? How would you feel if I gave you a test or a quiz and gave it back to you 2 weeks later? Hell, you guys leave and you want to know the next period what your score is. Why is your expectation have to be more important than mine? Do you understand or no? How would you feel if I took 2 to 3 weeks to finish your test? Wouldn't you be mad? Wouldn't you say, Riker's lazy? Wouldn't you say that? You guys do. I hear you talk about other teachers. Yeah, I don't care. I'm videoing. It's going on the website. I don't care what I say. Just tell, that's what you are. You're me people. You're all about you. Right? I ask you to do one simple thing. Print my notes, print my handouts. Print my vocab. First hour. 2 guys. Guess what they did? Xavier? They emailed me last night and said, hey, my printer's not working.
No, my printer works.
Dude, whatever.
My bad.
All my point is they had an excuse too, but they texted me and said, hey, I can't print the notes. Would you print a copy for me? Guess what my response was?
I don't need your phone for me. I'm fine. I'm gonna get it.
Do you have them printed? Do you have them printed?
No.
Why? Because you needed to know what they look like? Give me a break, dude. These 2 dudes are nothing but laughing at you. Crazy. The other one said, hey, my printer makes it print so I only see half of them because the words are this big. Right? It's like he's Stevie Wonder and can't see. They made him this big. He says, would you print them? I can't correct my printer font. Can you print me a copy? I said, sure. So he asked me what it should look like. And I emailed it to him. It's all about communication, dude. Those pretty eyes, that pretty smile, that nice personality didn't go and fly with me. Right? So, let's get with mixtures. I'm going to request you every year that you're in school. By the time you graduate, I'll have you where you need to be successful on your own. And don't think I don't like you, I do. I just think it's funny. Okay, so mixture. I gave you about 7 words to know on this page, right? Was it mixture the first one? So if you look at the definition of mixture, it's a combination of 2 or more substances where the properties or substances do retain their original chemical properties. If I change this word do to don't, what did I just define, Langston? A compound. Isn't that the quiz I just handed back that you did? Didn't you put 2 things together? What were the 2 things on the quiz? What were the 2 elements on the quiz? Magnesium and iodine, right? You made magnesium iodide. That's a compound. Was there a chemical reaction there? Yes. Yeah. So a chemical reaction is going to occur in a compound. Let me give you an example. You ever bake a cake or bake cookies? If you haven't, could you imagine what your mom does? She puts sugar, flour, eggs, milk, butter, if it's cookies, chocolate chips, or whatever the hell else you put in there, right? Mix it up, put it in the oven, voila, out comes the cookies, out comes the cake, right? Can I get the eggs back? Can I get the butter back? The sugar? No. That's a chemical reaction. You just created a compound of a bunch of different things. So, is that a mixture? No, that's a compound. So what the heck is a mixture? Right? Well, football season, right? One of the things, if we were able to tailgate, right? Not that you guys still don't tailgate, because you guys don't really follow rules. You're quarantined, you still go do the stuff you do, right? And jeopardize everybody else, right? So I'm sure some of you have tailgated, got together, watched football. One of the foods that you probably ate was trail mix. Think about what's in trail mix. Give me one thing, Coco, that's in trail mix.
Pretzels.
Pretzels. Give me another.
Nuts.
Nuts. Give me another. Berries. What the hell kind of trail mix is that? How about M&Ms? How about M&Ms? How about cereal, like Cheerios or Rice Chex? Yes, no? Berries. Hey, it's way too early for me to start drinking. Dude. All right, do you get the idea though? You know all the different things together? Can you pick the berries out of your trail mix, Xavier? Yes. Can you pick out the nuts? Yes. Can you pick out the pretzels? So is that a compound?
No.
That's a mixture because they retain their original properties. Do you understand the difference?
Yeah.
By changing one word, do to do not, I go from compound to mixture. We've already learned about compounds. Today we're learning about mixtures. Now, think back to what I showed you at the beginning of, or the end of Thursday's class. I showed you this, did I not?
Yeah.
Yes or no? And I asked you to write down this above the definition of mixture, right?
Yeah.
Okay. Next to it, you should write compounds don't retain. Compounds do have a chemical reaction. Now, how many different mixtures did I say we were going to go over today?
3.
I was going to go over 3, but I'm doing 1 today. The other 2 tomorrow. Okay? The one I'm talking about today is solutions. Okay? You understand? So 3 types of mixtures, and I'm talking about solutions today. Okay? You following me? Okay. Now, there were some key terms that I talked about with this type of there were some key terms that I talked about with solution. The first two are solute and solvent. I told you to circle or star them, didn't I? Right? Here they are. Solute and solvent. Okay? If you look at the definition of a solution, it says one or more substances uniformly distributed into another substance. Would you say that's a book definition? Yeah. Is that an everyday common language definition that I would give you? No. But that's what a solution is. So let me give you an idea of what exactly in everyday terms a solution is. Here you go. One substance gets dissolved into another. One substance gets dissolved into another. So how many substances involved in a solution? 2. What's the job of one of them?
Getting dissolved.
Getting dissolved. What's the other job of the other one? To do the dissolving. You got one getting dissolved, and you got one doing the dissolving. That's what's happening in a solution. Now you might say, I don't know what dissolve is. Okay, did anyone ever not make a glass of Kool-Aid? Do you know what Kool-Aid is?
Yeah.
How about lemonade?
Yeah.
Take out the little container, right? Take a spoon, scoop up a couple spoonfuls of sugar, put it in a glass, and add what? You add, what the hell kind of lemonade? 2 scoops of sugar from the container that has the lemonade in, and what do you add to the sugar?
Water.
Water. Okay? Yes or no?
Yeah.
Then you stir it up and you take a drink and it's lemonade, correct?
Yeah.
Okay. So, how many things involved?
2.
5.
Oh my god. Holy crap.
I did not say 5.
You said 3! Give me the 3.
Lemons, water, sugar.
Dude, there's no lemons. It's in the mixture. It's like a country time can of lemonade mixture concentrate.
I make some better ones.
I'm sure you do. You probably got a third thing in there, a little Tito's. You're good to go, dude. Right? All day. All day. I'm talking about the pre-made concentrate, dude. Okay? How many things are involved?
2.
The lemonade sugar and the water, correct?
Yeah.
So one of them gets dissolved, one of them does the dissolving, right?
Yeah.
Which one gets dissolved?
The sugar.
The sugar. Which does the dissolving? Water. Which one's the solute based on the definition that I asked you to learn?
The sugar.
The sugar. So the solute gets dissolved. The solute gets dissolved. It's the sugar. And the solvent does the dissolving. It does the dissolving. Now, anytime water is one of the 2 substances in the solution, it is always going to be the thing doing the dissolving. So it's always going to be the solvent. Do you understand?
Yeah.
If water's one of the 2, it's always going to be the solvent. What's the word for water in Spanish? Agua. What word that I asked you to underline and highlight yesterday has the root word agua in it? Aqueous solution, down at the bottom. Aqueous solutions have water as the solvent. So water is called the universal solvent. Is water always going to be that one thing? No. But when it is one of those things, it's always going to be the solvent. It's always going to be the thing doing the dissolving. What can you tell me about the amounts of solute compared to the amounts of solvent? Solute is always going to be a smaller amount than the solvent. Absolutely. Okay? Do you understand what a solute and a solvent is? So in our example, the sugar is the solute getting dissolved by the water, which is the solvent. Got that? Yes or no? Got that. Okay. Now, how many have ever tasted that lemonade and it didn't taste sweet enough? So what'd you do, Kennefic? I put more solute in. right? And what did it taste? Sweeter. How many have ever taken a sip of something and it tasted too sweet? What did you add? Added water, the solvent. That's called dilution. You diluted it. What word did I ask you to underline would represent what I just explained 30 seconds ago? What word did I ask you to underline would represent what I just talked about? Tomas. Concentration. So what is concentration? It's a measure of solute over solvent. Isn't it? It's a measure of solute over solvent. It's a fraction. If I increase solute, what happens to the concentration? If I increase solute, what happens to, if I increase the numerator of a fraction, what happens to the number? Doesn't it go up? Right? So if I increase solute, which is the numerator, what happens to the concentration? It goes up. It tasted sweeter. That's what Kennefic said. So concentration goes up. Right? If I increase solvent, which is the denominator, what happens to the number? It goes down. So what happens to the concentration? It goes down. This is called dilution, which is another word that I didn't put on there, but you should know. Okay? Do you understand what concentration means? Okay? So when you look at my notes, you can see that word concentration, right? So concentration is basically this. How much of this over how much of that? That's all it is. And that's what this is explaining to you. Okay? Now, how many have poured in so much sugar that after they got done drinking the glass, they saw sugar in the bottom of the glass? Right? So what can you tell me about that sugar? It didn't get what? It didn't get dissolved. That point, which it no longer is able to be dissolved by the solvent, is called what point? It's the other word I had you underline. It's called saturated. So at some point, the solvent will no longer be able to dissolve the sugar or the solute. That's called saturation. What could I do to dissolve the rest of that sugar, though? Add more water or more solvent. But what do I do to the concentration then? I make it go down so it tastes more or less sweeter? Less sweeter. Do you get those terms and what they mean? Okay? I use another example in my notes as salt water. Right? Because it's salt water, what's the solvent? Water. What's the solute? Salt. The salt disappears. It gets dissolved. So you're saying that's a chemical reaction. That's a compound. No, it's not. The salt's still there. How do you know? Taste it. Can you taste the salt? Just like you could taste the sugar? So you know it's still there. How can I prove to you that it's still there? Couldn't I evaporate the water? If I evaporated the water, what would be left in the glass? The salt or the sugar, depending on which one I used. It didn't go away. Okay? So, when you look at these notes, right? Do you see the words that I asked you to talk about? Right? Aqueous solutions. Solutions which water is the solvent. Okay? This is important. Why? Why is this the most important one in biology?
Just like water's the universal solute.
Water's the universal solvent, and every living organism is what? 80% water. So what are all the solutions pretty much in our body? Aqueous. That's why we can't live without water. It's one of the most important compounds. Why can I call water a compound? Why can I call water a compound? It's made up of two or more substances, right? What are the substances? Hydrogen and oxygen. I want you to think about what hydrogen is. What's hydrogen? Isn't it a gas? What's oxygen? A gas. When you put them together, 2 hydrogens with 1 oxygen, what do you get? Would you say their properties changed?
Yeah.
When properties change, is that a mixture?
No.
It's a compound. It's one of the most important compounds to living organisms. Look at the notes that I had you print for today. What's one of the most important compounds? I put it under organic, or I put it under inorganic.
Carbon compound.
Inorganic.
Water.
What is it, Kolka?
Water.
Water. It's under inorganic compounds. It's one of the, if not the most important compound to all living things. And our solutions are that of aqueous type. And that goes for every organism, not just humans. Okay? Do you understand what a mixture is? Do you understand the difference between a mixture and a compound? Do you know the parts of a mixture? Do you know the parts of a solution? Okay? If not, ask me now, because I'm going to the next set. Okay. So, what's the next set in my notes underneath solutions? Acids and bases, right?
Yeah.
Right? What are the first 2 terms in my notes that I had you highlight?
Acidity and alcohol.
Acidity and alkalinity, right? Yes, no?
Yeah.
Okay? So, underneath acidity, what did I tell you to underline? In the definition of acidity, what did I tell you to underline?
You said no.
Hydronium, thank you. Somebody was listening in Zoom, right? Instead of playing with their doggy. Right? Hydronium, correct?
Mm-hmm.
Yes, no?
Yeah.
What did I tell you to underline under alkalinity? Hydroxide, right?
Yep.
Yes, no?
Yep.
Okay, next to alkalinity, in parentheses, I want you to put the word base. Alkaline substances are bases. Alkaline substances are bases. Okay? So when you hear me talk about acids, you know what I'm going to talk about. When you hear me talk about alkalinity, I'm talking about a base. Okay? Now, look at the definition of acidity. It measures how acidic something is. What does that mean? It measures the hydronium ions. What's an ion? Come on. We just got done. What's an ion? Besides him. I'll give you a hint. I'll start you out. An atom or a negative charge. It's just an atom with a charge. What's an ion that's positive tell you? You're killing me. What's a positive ion telling you? It's got... Thank you, I know that, really. But what's it really telling me? Say it. It's got more what? Yes. It's got more protons than electrons, right? Yes or no?
Yes.
What's a negative ion? It's got more electrons than protons. Why would one have more than another? Because it was bonded how? I know that. What type of chemical bond? What are the 2 types of chemical bonds? Ionic and covalent. You guys don't study. Good luck. You guys are going to get ripped a new one on this test. Seriously. Start making up your excuses now so when you don't have to come in to take the test on the test day, because then you get the makeup.
How long do you think that, like, how far is it?
It's coming next week. At this rate, I'm going to finish the notes as quickly as I can and try to get it for Friday so I can grade them, so I can post them, so the weekend could be hell because your parents see your grade. That's my goal. That's my motivation. Right? I know. This is what I look at for most of you. Right? No, most of it's like this. That's what I'm seeing from some of you. It's a good look. Okay? So, acids have more hydronium. What's the formula for hydronium? It's H3O positive. How many elements there?
2.
Or elements.
2. Hydrogen and oxygen. How many atoms? 4. And because of the plus sign, it's got one more proton than electron, right? So this was a giver or receiver? It was a giver of electrons. For a base that has alkalinity, right? It's measuring how basic something is. In other words, it's measuring hydroxide ions. Hydroxide are OH negative. How many elements?
2.
How many atoms?
2.
How many electrons compared to protons? One more electron than protons, right? Do you see that or no? Okay. This is hydroxide. This is hydronium. Acids have more of this than this. Bases have more of this than this. How can I write something that has more of something than another? I'll give you a hint. Think of your math class.
Greater, less than.
Greater than or less than. Right? So, for acids, what would I write?
H3 0 plus is greater than.
H3 0 plus is greater than OH negative. Perfect, Kolka. Right? So what would be a base? Really? H3O positive,
Less than.
OH negative. Right? So when you look at acids and bases, what are you comparing? I'm looking at how many of hydronium versus how many of hydroxide, right? If I have more hydronium, I'm an acid. If I have more hydroxide, I'm a base. What if I'm this? Thank you. I know what the equal sign means. Am I an acid?
No.
Am I a base?
No.
I'm a substance that's considered neutral. Do you guys read the book? I know you don't, because I don't collect it. If I collected it, you'd read it. You wouldn't really read it. You'd just do the 5 questions. You'd go right to the 5 questions and try to figure out the right answer. And you just keep plugging in the wrong one until you get to the right one. But that's not how you learn, okay? So do you see these inequalities can tell me which is an acid, which is a base? Okay? So when you look at my notes, some of you, the looks on your faces when you walk in here is just utter dread. I can see it. They're like, oh crap, I got to deal with him again. And you know why? Because you do nothing to prepare for my class. Right? Others come in and they're like, this is going to be good because they like to see me get riled up and get all excited. They probably go, God, I wonder what he's going to do or what he's going to say to whom today. I just hope it's not me. But you like taking that chance. Others come in and are ready to go and they have no fear whatsoever because they know what's going on. So they're just looking for the other entertainment and they're making bets on which guy's going to get lit up today by him. It's true. And you got me for 2 hours in a row. That's got to be like double the pleasure. Okay? So, when you see this part of my notes, isn't that kind of what I just said verbally as you read through that? So, what is an acidic solution? It's a substance that contains more hydronium than hydroxide. Didn't I just write that as this? Did I or not? Okay, for a base solution, which is alkaline, Where do you see the word alkaline in everyday life? What? Alkaline water? No. Those little things you call calculators that you change the batteries for. You ever look at the package of batteries that you buy? What's the word in front of battery? Alkaline. Alkaline batteries. Okay? So, those are base solutions. They contain more hydroxide than hydronium. So OH negative is greater than H3O positive. Right? Now, some characteristics. One, acids taste sour. And they tingle and burn your skin all day. Okay? And they do it quickly. How many have ever eaten citric fruit? Oranges, lemons, limes, grapefruit. You ever get that juice in your eye? Did it burn? Because it's an acid. Right, it burns. Right? And it burns quickly. How can you take away some of the burning?
I put honey on my eye.
Okay. That's good. I'm just saying, I just asked the question. You gave me an answer, not the one I'm looking for, but it's okay. Water! Because what does the water do? It dilutes it without the stickiness and you're not being chased by bees. Right? Okay? Does that make sense? Okay? Bases. Okay? They taste bitter. Okay? How many washed their hair this morning? I know that's probably going to be less than half. Right? Because I can smell you. Okay? So you use shampoo. Do you ever get shampoo in your eyes? Does it burn? Yeah, so it acts a little bit like an acid, but the burn is much slower and longer. It's actually more painful because of the longevity of the burn. Okay? And it feels slippery. Isn't soap slippery? So soap and cleaning detergents are bases. Okay? They'll still burn. And they have a bitter taste. Those are characteristics of bases. Okay? So, shampoos, soaps, cleaning detergents, right, are examples of bases. They have more hydroxide than hydronium. How many have actually used cleaning detergents before? Have you used them for a long period of time without gloves? Yeah, if you use them without gloves, guess what your hands are going to start to do? They're going to dry out and start to crack and burn. Right? How many have a hot tub or a swimming pool? How many have ever been in a hot tub or a swimming pool? You ever been in a swimming pool or a hot tub where your eyes burn after you're done? Yeah, the people you got into the hot tub with aren't taking care of the water. The water's not neutral. It's either acidic or basic. That's why your skin itches and burns. That's why your eyes burn. Right? If you check the water of your pool or your hot tub regularly, you'll see that occasionally it will become unneutral, especially after large parties when you have a lot of people using it. You should check the water because you might have to add chemicals. How many have ever had an upset stomach where they kind of have indigestion and they can feel the burning sensation in their throat? Right? What do you do for that? Take Tums. So, what do you think's causing the burning? The acids in your stomach. So what is a Tum? If it's the acid in your stomach that's causing the burning, what are Tums?
Alkaline.
They're a base, right, Kolka? They're a base. So you take a base to offset it, right? If you don't have Tums, you can take Mylanta, Pepsid AC, Pepto-Bismol, Rolaids. Those are all bases. They taste chalky, don't they? Right? That's a base to neutralize the acidity. If you don't have those products available, what can you go to the fridge and drink? Milk. Milk is a base. What don't you want to drink? Pop, orange juice. That's just making it worse. It's more acid you're adding to your stomach. Do you understand? So those are some of the products that you can take to relieve that type of symptoms. So in your pool, if you test the water and it shows up acidic, what do you add? A base. If it shows up as a base, which can still burn you, you add acids. Do you follow me on that or no?
Yeah.
To try to neutralize it. Do you know what that scale is called that we use to measure hydronium versus hydroxide?
pH.
It's called the pH scale, right? It's one of the things I asked you to remember, right? The pH scale starts at number 14 and goes all the way down to number 0. So what would be neutral?
Zero.
He says 0, he says 7. What would be neutral?
Zero. No, it's 7. Oh, so zeros like detergents. No, it's 7. Look at the sun.
None of you read. I don't know why your parents wasted their time buying you a book. Maybe some of you can't read. I don't know. Maybe you need one of those talking books that reads to you. Because that's what we do. Everything's done for us. 7 would be neutral. It's in the middle. So what inequality would I draw for neutral? H3O positive equals OH negative. Correct? They're equal. Hey, you got up this morning. I guess one of the things you probably did was urinate. You probably peed, right? Okay? Right? Correct? Okay. Where do you think urine falls on the pH scale? So you burned when you peed this morning. So you were peeing fire. Right? If you urinated and it burned, that's a whole other problem that might be an STD. And I'm not joking. Right? It burned?
No.
That's what you just said.
I didn't.
Right. It didn't burn, did it? Right? So it's around 7. It's pretty close to equal. Correct? Okay. The shampoo that you got in your eyes, it burned, didn't it?
Yeah.
It's probably not close to neutral, is it? Where is it? Above or below 7? This is what I love. It just totally reaffirms that none of you read crap when I ask you to read it, right? Because the pH scale's right there on in the reading. It's up here, right? So soap is up here. It's a base, right? So it's got more hydroxide than hydronium. I know you guys, when you have Zoom days and long distance learning, you pretend it's what? A day off. You do. It's terrible. It's on you. So I have more hydroxide than hydronium when I'm at soap. So I'm up on this side of the scale. So above 7 is what? An acid or a base?
Base.
It's a base, because I told you it's, right? It's a base. Right? Yes?
I just thought it was the other way around.
Yeah, you thought wrong. Okay? So, below 7 must be an acid. Right? So, an acid is going to have more hydronium than hydroxide. Correct? Do you follow me?
Yeah.
Okay, so that's like the stomach acid that burns when you throw up or you burp or whatever. That's what's causing the heartburn you were talking about, Ed. Okay? So, let me ask you this. Hey, you want a pillow? You sure? I'll get you one. Okay. That was a fair question. I was just trying to help them out, make them comfortable. So, here's my question. If I'm, don't go, if I'm at 6 and I'm at 2, which is a stronger acid?
2.
6.
6 is closer to neutral, so it's weaker. If I'm at 13 or 9, which is a stronger base? 13. You guys are terrible. You're just absolutely terrible. Seriously.